All right, here's a 6.2 homework assignment, kind of similar to what we did in 6.1, where we're coming up with the graphs of different trig functions. But as you know, in 6.2, we focus on secant, cosecant, tangent, and cotangent. And the fact that this homework assignment is significantly shorter is intentional. I really want you to be good at all the stuff we did in 6.1. But 6.2, I more just want to kind of expose you to these topics. If you got a little bit lost on some of the videos, but we're able to pick up most of the information and get through this homework assignment, I think that that's great. That's everything you'll need for our class. So the first two questions deal with untransformed versions of our trig functions. So in this first one, they give you a graph and you're supposed to figure out which function is graphed here. So ideally, I guess you'd know enough about the untransformed versions of each of these different graphs and just be able to match it up with this picture, select your answer, and move on. Question two is the same idea, except it's more of a matching idea. So they give you all these different graphs, and you're supposed to figure out this first one. Is it which of these different types? Same one for the second, third, and fourth. The key thing to note here are all these graphs are the non-transformed versions of them. So this would be the first of the videos I made in this section. The next few I think will go pretty quick for you, but there is one little tricky thing that I want to point out. In each of these questions, they just ask you about the period and the horizontal shift. And you're like, oh, that's easy. Period is just 2 pi over b, and horizontal shift is negative c over b. Almost. The period of sine, cosine, secant, and cosecant is 2 pi over b. But the period of tangent or cotangent starts out just being equal to pi, not 2 pi. So when you have a transformed version of tangent, you don't take 2 pi and divide it by b, you take pi and divide it by b. So be careful. If you have tangent or cotangent, the formula for period is a little bit different. Horizontal shift is the same idea though, negative c divided by b. And what they want you to do is enter the absolute value of the phase shift here. And then if it was a negative number, just say you're going to the left. And if it was a positive number, say you're going to the right. Exact same idea for 4 and 5, except instead of transformations of tangent, it's transformations of cosecant and secant. Then you get to the really hard problems. The good news is there's only 2 more that are required that are left. It gives you this graph here. This is a transformed version of one of our different trig functions. So you're going from the graph to the equation. I think this will correspond with the last of the videos that I made in this section. Maybe you can draw a sine or a cosine wave that kind of informally speaking goes in between this graph and come up with the equation of that sine or cosine wave and use that to come up with the equation of this graph. And if that wasn't enough, you get to do it again here in question 7. Note that in both cases, your x-axis is scaled in terms of ones instead of pi's. So the period here, for example, is 3, not 3 pi. So you'll be taking your period formula and setting it equal to 3. And I think that will end up giving you a value of b that contains the letter pi. That's okay. That's supposed to happen. Same thing will happen down here. This one's a little bit annoying because the maxima and the minima don't appear to fall at integer values. It kind of looks like this point right here has an x value of negative 1.5. It does, but if you couldn't tell that from the graph, maybe you could first come up with the vertical asymptotes at negative 3 and 0, and then figure out that halfway in between negative 3 and 0 would be when this upside down u here is at its highest point. Anyways, 6 and 7 should be pretty similar to each other. And then you get to 8, which is kind of the same idea, except now it's a transformation of the tangent graph. This is a really hard problem. That's why I made it extra credit. This is the last example I did in the last video. I think if you follow through that pretty closely, you can come up with the solution to this one. But if you don't feel like doing it, don't feel too pressured to do it. The fact that coming up with the equation of a tangent graph is only extra credit in this homework was intentional. I don't think that being able to come up with the equation of a transformed tangent function is a really appropriate question for a Math 112 class. It's probably a little bit too hard. But if you want to get the extra credit, give this one a shot. I think you have a video that'll walk you through it. And then that's the end of this homework assignment.